absolute values can be quite tricky, and whether you're solving them as an equation or an inequation, these three simple rules take all the trickiness out of them and make them really straightforward. Now remember what absolute value brackets mean. They mean the thing that's inside the absolute bracket could be positive or it could be negative, but either way we're just going to take the overall size of it and remove that negative sign if it is negative and make it positive. So if you've got something inside some absolute value brackets, and we've written f of x here because what we're saying is there could be some function of x. It could say x minus 2 in there. It could say x squared plus 5x minus 9. It could say anything at all that has a bunch of x's in it. So if we've got some of this xy stuff inside these brackets and it equals something, let's call it a, then one thing we know is that all of the stuff in there might be equal to a, but it actually might be equal to minus a, in which case we're going to make it equal to a with the use of these brackets. So the first thing you should do to solve it is to just write two simple equations, because that takes the absolute value brackets away. Say f of x is either equal to a or it's equal to minus a. Alright, now with inequalities it's a little bit more tricky. It depends whether it's a less than or a greater than that you're dealing with. Now think about this carefully. If the absolute value of something is smaller than a certain number, that means that if it is positive, it's a smaller positive number than this one. But if it's negative and we take that negative sign away, it's also needing to be a smaller number than this one. So you can write it out as one inequality like this. You can say that the function of x must be smaller than a, but it must at the same time be bigger than minus a. Does that make sense? Now if you have a greater than sign here, then what you're saying is the absolute value of f of x is really big. It's even bigger than a. So if it was a positive value, all of this anyway, then it would be a bigger positive number than a. In other words, f of x would be bigger than a. But what if this was a negative number? For it to actually make this statement true, it would have to be a really large magnitude negative number. In fact, something that's a long way to the left on the number line, so that when you remove that negative sign, the absolute value of it is still going to be bigger than a. So we can say that f of x must be bigger than a or smaller than negative a. Does that make sense? Because if it's a large negative number, then when you take away the negative, it will still be a large positive number, bigger than whatever it was you were told it's bigger than. So let's look at three examples here, one that's like each of these so that we can see how to use this. You'll notice that all three of them have got virtually the same question, just with a different sign in it. So when we're thinking this one through, we're thinking, well, 5 minus 2x might be positive or it might actually be negative. We don't know, but the absolute value of it is 7. That means it could be negative 7, and we've just given the absolute value to turn it into 7. So the first thing we do is we say 5 minus 2x either equals 7 or 5 minus 2x equals negative 7. And now we've got two little equations to solve and we'll get two answers. So solving this one first, if I subtract 5 from both sides, minus 2x is 2 and x must be negative 1. But over here, if I subtract 5 from both sides, I get minus 2x is negative 12, so x must be 6. Now at the bottom of these ones, it's good just to come up with your answer in one go, minus 1 or 6, so that way you feel like you've made your answer really clear. Now for the middle one, if the absolute value of this is less than 7, then the 5 minus 2x must be smaller than 7, but must also be bigger than negative 7. Now, solving something like this that's got 3 parts, it's exactly the same as solving an equation with 2 sides. Just do the same thing to all 3 parts, just like you would normally, and everything comes out. So first thing to do is to subtract 5 so that I have my minus 2x on its own. So I need to subtract 5 here and subtract 5 over here. Next, I want to get the x by itself, so I need to divide everything by minus 2. So dividing this by minus 2 gives me this, dividing this by minus 2 gives me this, but when you divide by a negative, you have to flip the signs, and that gives me this. Now, we never normally write the signs around this way. It's not wrong, it just looks sort of awkward. We normally, if we have something in between two things, we like to write the small thing first, because it's reminiscent of a number line that has smaller numbers going to the left and bigger numbers going to the right, which is what we expect. We don't normally write the smaller numbers on the right and the bigger numbers on the left. However, what we've done here is not mathematically wrong, it just looks a bit awkward. So at the end here, I then rewrite it and say, therefore, x has to be between, and I put them the other way around, -1 is the low one, and 6 is the high one. And that's my answer. Now for the last one. If 5 minus 2x, the absolute value of it's greater than 7, then 5 minus 2x must be greater than 7, or if it was negative, then 5 minus 2x must be less than -7. So solving both of these separately, let's again subtract 5 from both sides and then divide both sides by -2, but when we do that we have to flip the sign. Same over here, subtract 5 from both sides, divide by -2, and when we do that we have to flip the sign. So here we have the situation where x is less than -1 or greater than 6. Now you'll see that it can't be both at once. The other thing that you'll notice is that all of these equations and inequations have the same two key points that we're working around. And what you'll notice is that with these two, you either have a region, for example here, between -1 and 6, we want all the values of x that are in between them. Whereas with this one, we have our -1 and we have our 6, but we want everything that's out this side or out this side. So it's either a two tails situation or an in-between situation.